Without too much further ado, I'd like to introduce David and Eduardo for a rousing discussion on cross-site scripting filters and how to attack them. Both are interesting in a number of ways, and I'll leave them to provide detailed introductions of themselves briefly. But one thing of note is they both recently changed jobs. Eduardo is from Mexico, but he's now living in China, which he says is way cool. So maybe he'll talk a little bit about his work, and we can help him with his jet lag. And David has also just changed jobs, is now with Cigital in Virginia, and has moved out there. So without further ado, here's our speakers.
Thank you, Ray. Can you guys hear me? Okay, it's hard to tell always if the audio's on. Okay, sounds better now. So yes, I'm David Lindsay, and as Ray just mentioned, I do work with Cigital. I just moved out there. It's been a fun move down from Boston down to Virginia. And for our talk today, we are talking about cross-site scripting filters and how to attack them. So to give a little bit more background on why we're qualified to talk on this topic, well, basically it's because it's something we both are interested in. We both have jobs with web application security. We both have spent a lot of time playing with different filters in work and for fun on our own time. We both are frequent posters and community members at the slackers.org website, which is a great forum for discussing cross-site scripting type issues and other related web application security issues. And we both had an extensive look at some of the filters that are out there. We haven't looked at everything, and a lot of the commercial filters that cost money to get your hands on we haven't looked at, but there are quite a few still that we have seen that we are discussing today. So. And in addition, in addition to just looking at these filters, we both have extensive experience actually developing bypasses for these filters. And as part of that, we typically responsibly disclose these issues to the different vendors so that they can get them fixed, and had a lot of good experience going down that route. So we wanted to put together a presentation on this just because it seemed like we were uncovering a lot of unique vectors to bypass filters, and we thought it'd be good to get some of this information out there. So that's what resulted in this presentation. So we already kind of did a brief introduction. Real quickly, I think everything here has already been discussed, so we'll skip that. For me, we already covered that, so I'll skip that. Okay, so let's talk about the basics. Well, at the heart of all this is cross-site scripting, and I imagine that everybody here in this room knows what that is. If not, you probably shouldn't be at this conference. So we're not going to go into the basics here in a lot of detail, but there are just a couple, ground rules that we wanted to establish. So first, well, here's some classic examples of cross-site scripting. Hopefully, everybody's familiar with these types of issues where an attacker is able to get malicious content into a website in a way that other users of the website will execute the malicious content. Your stereotypical example is to have a cross-site scripting attack that injects something like a cookie logger that will steal the victim's cookie, send it to a third-party website, and then compromise their account that way. For testing purposes, as a pen tester, we usually use something kind of even more simple than that. Just getting a JavaScript alert to fire is usually sufficient to know whether a website's vulnerable to cross-site scripting or not. So this is definitely, the basics. What we're going to be looking at are a lot of more advanced ways of getting to the same point of executing JavaScript. There's a lot of good resources out there for cross-site scripting issues, so I just wanted to throw some of these on here. Hopefully the trackers.org website will get put up soon so that can be a forum, kind of a public community place to track some of the different issues that relating to cross-site scripting and other web application vulnerabilities. But we still need to bug Arsnake and id to get that finished, so hopefully soon. So in the filters that we'll be talking about, the basic idea is that the filters are going to be that we're discussing are somehow trying to catch these types of cross-site scripting injections. And if they detect that, then either the filters are going to log and make note of that and still allow the request to go on, or else the filters can take some sort of action based upon the fact that they detected that. So in our case, we don't really care too much about which of those two routes it follows. We want to discuss bypasses that will avoid detection in the first place. So there's a few different filters that we're going to be talking about, and there's a kind of a fundamental difference between some of them. We're going to mostly be talking about two server-side filters that actually run on the server. So that includes mod security and PHP-IDS. And these both actually run kind of alongside your actual application. Then there's the other two filters that we're going to be talking about are NoScript and the Internet Explorer 8 filters. And these are both on the client side, which is kind of a different paradigm than you usually think of, but it also can be a very effective place to catch cross-site scripting issues. And so we'll talk about that in a little more detail. And then you have ones like Imperva and other inline web application firewalls, IDSs, and so forth, that usually sit somewhere in the middle. And for the most part, we're not really talking about those today, not because they're not interesting, just because we thought these others were more interesting. So like I said, we're not going to make a distinction whether a filter is being detected or blocked. We just want to avoid the filters to begin with. So that's pretty much for the basics. So hope nobody had any questions on that. So let's talk about some of the more kind of interesting things that you can do to get malicious content onto our web page. So the first one, this is still kind of basic, but not a lot of people know about this, but with HTML, there's a lot of different tricks that you can do to kind of obfuscate things. So one is that you can have an injection that just doesn't use white spaces at all. In this case, use an image tag with a slash after the image attribute, the tag name, and then you really don't need spaces between attribute names either. And it's just simple little tricks like that. Oftentimes are able to bypass a filter. So before I go too far down the road of these tricks, I want to just kind of give a little bit of a roadmap where I'm going. So I'm going to talk about a bunch of different tricks like this, and then towards the end, we will talk about some of the specific filters and how these tricks that we're talking about now will enable us to bypass them. So we'll see these different tricks showing up later, but usually in a somewhat more obfuscated form. So these are kind of still just the background that we need to understand some of the attacks that will be coming later on. Okay, so next, this is kind of a cool one that Alex K. or Kuza pointed out to me a while ago. And this is one way where you can get JavaScript to execute without using event handlers and without using your kind of classical injections like iframes or using the source parameter. Well, it actually does use the source parameter, but in kind of a novel way where it actually uses the object param tag like you can see on the slide. So I kind of thought that was pretty interesting just because it's not a very common, well-known way of executing JavaScript. The second example there with the object data tag is another where you're avoiding the source tag, and a lot of filters aren't necessarily going to recognize the data tag as a source for JavaScript injection. So little things like that can often be useful. Next is the isIndex HTML tag, which is pretty interesting. isIndex is, I honestly don't even know what it does on an HTML page, but I do know that you can execute JavaScript with it, so I thought that's pretty neat. And so I have a couple different variations of that here. And another thing I wanted to point out with this one is just that quotes are oftentimes not needed when injecting things, even if you're including JavaScript, so it's kind of a good thing to know. Okay, next we have, this is using an injection with an image source tag, and on this I just wanted to point out that you can, within the event handler, the JavaScript that's actually being executed, you can refer to other parts of the other attributes within the tag. Oops, go back one. You can refer to other attributes within that tag and include additional content that way. I believe the MySpace worm that Sammy came up with kind of used some variations on this. So, and it also can kind of really help obfuscate and obscure things by doing it that way. Okay, next, we have one XHTML trick I wanted to point out, and that's that you can include, if you're injecting onto a page that is rendered as XHTML, you can do something like this in order to inject an alert. And what's kind of nice about this is, if you notice, the beginning has a namespace, and that, in this case, we just called the namespace X, but that can be appended to the beginning of the script tag. And so any filter that's looking for open angle bracket script is going to miss something like this. So it's kind of a neat kind of way to avoid certain filters that way. Okay, next let's talk about a few different JavaScript tricks. These are my favorite. I really didn't know a lot about JavaScript just 3 years ago, and was at the RSA conference and entered a contest that Security Innovation was putting on, and one of the injections required me to know a little bit about how to do comments in JavaScript, and I didn't know how to do it. And so after that, I kind of thought, there's really a lot of interesting things that you can go on with JavaScript that I know nothing about. So I kind of took that as a personal challenge to figure out everything I could about JavaScript. So there's a lot of neat things you can do here. So first is just one way that you can get JavaScript to execute is by using the location, what do I call it? What is location? Object? Yeah, the location object in JavaScript. And there's you can use function calls with location in order to execute it, but what's nice is that you can also do something like this, because as you can see, you don't even need quotes or parentheses necessarily to inject your JavaScript. So like in the second case, we just assign the name variable to location. So one question that a lot of people are probably wondering is, well, what's name? Well, that's kind of a really neat trick that you can use to reference some other string. So name is a variable in JavaScript that refers to the parent frame's iframe attribute if it's being called that way. Otherwise, it's just blank. But if your page happens to be embedded in iframe and that iframe has a name attribute, it'll be that string. So that actually provides this really nice avenue for an attacker to get malicious content rendered. So they can have on the malicious attacker's website, evowebsite.com, the attacker would have an iframe with name equals and then a bunch of JavaScript, and then source equals, and then the vulnerable page that references that's vulnerable to cross-site scripting. And then the injection in that vulnerable page will just have to do something as simple as location equals name. And there you go, you have cross-site scripting. So that's actually a pretty cool trick that we'll see later on. The downside is that it kind of takes away some of the oomph out of persistent cross-site scripting, because you have to have the third party involved, and so then you're back to the case of persistent cross-site scripting where you need to get the victim to navigate to some third party site. So, but still, it's a nice trick. So we'll see that later on. Another, there's kind of some variations in that. And so instead of using the name variable, we can use something like location.hash.slice1 as the argument. And what location.hash refers to is in the URL, the last part of the URL, you can have this optional hashtag with some text up there. And that can be used for referring to anchors within a page to navigate to them. Well, we can also use this in JavaScript to put arbitrary JavaScript as well. And one kind of cool thing about the hashtag is that you can use that symbol, the pound symbol, as valid JavaScript within the Mozilla-based browsers, within Firefox. So in that case, it's referred to as a sharp variable. And I kind of, at the bottom of the page here, have the sharp variable as an object tag. Oh, I guess it's just on the sides, isn't it? Okay, so the sharp variable is in Firefox can be a legitimate JavaScript, and so you can actually do an injection without having to use the .slice at the end. You can just do location equals location.hash. And the other really nice thing about this trick is that everything after the hash symbol stays on the client side. It never gets sent to the server. So if you do an injection like this, the web server will see the location equals location.hash somewhere in the reflected part of the cross-site scripting, or the persistent part even, but they're never actually going to see what's coming after the hash variable. And so it's a really clever way of, I guess, hiding the actual true payload of a cross-site scripting injection, because it's not getting sent to the server. So it's very useful for that. Some tricks you can do is things like, instead of doing document.cookie, you can eliminate the dot and kind of include it as a string using this alternate syntax. And it's really nice to be able to do things like this, because once you can put something in JavaScript inside a string, that allows you to kind of morph it and manipulate it in countless, millions of different ways. So you can break up the string, you can encode it in different ways, you can reference it in different ways, and So putting things in strings like this is actually really helpful when you're trying to bypass filters. And then the last one is just kind of another different trick you can use in order to avoid using dots in your JavaScript. I have seen cases where periods or dots are actually filtered out, and so sometimes you do have to do things like this in order to get injection to work. Next, we have the document.refer. So that's just another place where you can include malicious content. And so again, this would be another two-stage injection, as I like to call them, where you have the actual payload, or the actual vulnerable page, and you inject something like what you see on the screen here, but the actual payload is going to be embedded somewhere else. In this case, it'd be 10 characters after the beginning of the refer. And so that's something that can sometimes be controlled by the attacker. The next one, the eval, uses location.string. So well, actually, this is a typo. This is supposed to be location.search, right? Yeah, I typed this up wrong. It's supposed to be location.search. I'll fix that. So location.search refers to the part of the URL after where all the get parameters come, basically. It starts with a question mark, and then you have name equals value, ampersand name equals value, so on. So, and what's nice is that for most any site that I've seen, you can always include extra get parameters, and if the web server or if this application or the server doesn't recognize them, then it just kind of silently discards them, and there's usually no harm in including extra get parameters. So you can kind of abuse that in order to construct a JavaScript string like what's shown at the bottom. So you need to use the question mark as a ternary operator in JavaScript, and that's why you have to append the 0 at the beginning. So you do 0 plus location.string, and you end up with something like this string at the bottom. And the actual injection will go through because we are using comments to kind of ignore all the middle stuff that's in the injection. Oop, there we go. Got to go back. Okay. There we go. So that's, again, is just another way of kind of hiding where the actual injection is. This setter trick is kind of nice because it doesn't use any parentheses at all. And the setter notation like this, I believe, only works in Firefox. And it's actually, if you go to Mozilla's website, for the last 2 or 3 years, you can look it up how getters and setters work. And they always mention that this syntax has been deprecated and that it will probably be removed at some point in the future. But it's been, 3 years now, it's still there. Well, so that just makes it more fun for people like me. So I really like this notation. Actually, there's a good story about how you can use it to bypass, but maybe we'll tell it later. So, so basically, what's neat about it is that by using the setter notation like this, you can avoid having to use the parentheses, which is very useful for getting by a lot of filters. Let's see here. Okay, so this is just another way of getting malicious content to execute. So in here, the injection would be something like eval and then unescape location. And well, location refers to the full URL string. And if you use the unescape like this, you can actually make the entire location string itself valid JavaScript, which is kind of cool when you think about it. So it's not only a URL, it's valid JavaScript. And the key trick you need to get that to work is to unescape the string, because that will let you to embed something like a %0a, which is a new line character. And when that's unescaped, then everything after that will be on a separate line in JavaScript, and then that can execute. And that really all comes from the fact that URLs all begin with something like HTTP:, and that is valid JavaScript. It's called a label, and is used for breaking out of loops in JavaScript. So that's valid syntax, and then the // is a single line comment in JavaScript. So that basically ignores the rest of the JavaScript until our unescaped new line character. So again, it's just another way of getting malicious content kind of embedded in a site using a two-stage injection. Okay, so here's another really, really clever and fun one. So in this case, we're kind of abusing some of the internal workings of JavaScript in order to get an alert to fire. And so this particular variation that we show here will work in Internet Explorer and Opera. And in both of these cases, they will show an alert box, but the alert doesn't really show anything. But just the fact that it's alerting in this situation is kind of interesting, and it kind of takes, to be truthful, I'm not entirely for sure exactly how it works internally. I believe that it's, since there's multiple browsers that support this kind of notation, that it's, I believe that it's not just a particular bug in any browser. It somehow probably goes back to the ECMA implementations of JavaScript. But, and I do mention Internet and Opera here, and I wanted to point out also that other browsers allow this this kind of notation as well, but you can't reference a function directly. So you can do kind of similar tricks with Firefox as well, but you just have to change things up a little. So pretty much all browsers allow something like this that I know of. Okay, so a couple months ago, Yosuke Hasagawa, I apologize if I slaughtered his name, he posted on the Slackers forum this really interesting way of executing JavaScript that didn't include any of your standard alphanumeric characters. And that kind of spurred this little mini contest in the forums on who could come up with the shortest version of that didn't use alphanumerics, that still would execute something like alert 0 or alert 1 in this case. And so these were a couple of the entries that people submitted that were pretty short. And I think these are pretty cool, helpful, because in some cases, well, an example that I've seen where I was injecting into JavaScript that I couldn't escape from, but I could still inject most of these characters that you see here. And the JavaScript that I was injecting was being cast to uppercase. And that made it really hard to inject certain, well, any of the ones that we've seen before, because JavaScript is case sensitive. You can't have eval in uppercase execute like you execute at all. It has to be lowercase. So doing something like this, you can kind of get around that problem. So at first it was just kind of like a novel trick, but it actually turns out it can be useful in certain cases to bypass filters. Okay, so another kind of interesting avenue is that in some places you can use VBScript to execute JavaScript. One scenario that's not mentioned here is the one that I just mentioned, where you have text that is being cast to uppercase, because VBScript, unlike JavaScript, is not case sensitive. So it actually can be useful for things like that. But in this case, this is something that I believe Gareth Hayes pointed out, that you can use event handlers and along with VBScript. And I'd never realized this before. I don't think a lot of people know this, but so you include an attribute like language equals VBS, and then your event handlers will treat whatever code is after there as VBScript. So that's kind of a cool trick. And we'll see that one show up in a little bit. And then another one is just something like this, where you can do eval name, but the VBScript equivalent can be executed like this with just a plus character, which is also pretty novel. So, and again, you can imagine like somebody trying to write a cross-site scripting filter. They could easily miss things like this because that doesn't include any of the normal characters that you might be looking for. So. Okay, so there's a couple that I wanted to mention that aren't necessarily possible now, but based on our understanding of the HTML5 spec that's being developed at the moment, these might be possible in the future. So one is that they might allow event handlers on closing tags in HTML, which would be pretty cool, because a lot of filters will maybe catch certain tag names, but won't catch if you have a slash character at the beginning of the tag name. So that could be a pretty interesting way to bypass in the future. Another unrelated one is that HTML5 is toying around with this notion of having seamless iframes. And in that case, you could do some sort of injection like this, which might work. And in this case, it's actually purely CSS. It doesn't even include JavaScript at all. So, and there's a lot of potential for different kinds of attacks like this, especially that are made even easier if they implement something like seamless iframes. So I don't have a lot of time to go into the details of what seamless iframes are, but basically the properties of the parent frame will be inherited on the subframe, allowing certain attacks to occur like this. So, if you want to know more information about seamless iframes, I guess the best place to turn to is the HTML5 specifications at w3.org, so you can get more information there. Okay, and a couple of just odds and ends. I wasn't sure where to throw them. So one is just that you can use the data URI scheme in order to inject things like JavaScript. And this is kind of nice because you can also include different kinds of encoding. So in this case, I used a base64 encoding in order to hide the injection. So if you don't know about it, then it's something that you could easily overlook. This is supported by all modern browsers. Now, I wanted to make sure I understood this right, because I didn't think originally IE supported it, but I guess Eduardo said that it is supported in very limited context. In image, as a source for an image, you can use this, but in most other situations where it'd be useful for executing JavaScript, it's not. So actually, the Internet Explorer has done a good job there in terms of not allowing these types of vectors. So. Okay, and another really interesting trick is you can use things like HTTP parameter pollution in order to avoid filters. Now, there's a whole talk that was given on this last spring by, who was it? Stefano Di Paola, and was Kuza part of that talk too? Okay, just Stefano. So he talked about this kind of novel way of getting cross-site scripting to work and other types of attacks. And so the basic idea is that a lot of browsers and servers kind of have different ways of handling multiple parameters that are submitted that have the same name. So in some cases, the first parameter might be accepted and the second ignored. Sometimes the second will be accepted and the first will be ignored. And in some cases, they both will somehow be merged in some sort of weird way. And in each case where you have different technologies doing different things, then that's kind of right ground for abuse. And so you can do things like this in order to create a cross-site scripting injection and break it up into multiple parameters and have it join in such a way that each individual piece would is not going to be detected by a filter, but together they combine in a vulnerable way. Also, I mentioned here Stefano and Luca, so I guess they were the ones who originally discussed this at the AppSec EU conference this spring. And while I'm on that slide, there's they cover the HTTP parameter pollution in a lot of detail, and so I highly recommend you check out the paper that I have there. It's definitely worth reading through. Okay, I think this is the last one here. This is just a couple different ways of including XML with JavaScript. So in one case, you can do XML inside JavaScript, and then you can reverse it around. You can have JavaScript execute inside XML. And so there's different ways you can get both of these kinds of things to work. And that's not something that a lot of people know about either, and that allows for a lot of interesting vectors. So there's still, I think, a lot of interesting exploration that people are doing along those lines. So. Okay, so that's it for my initial portion, but there's one other kind of background bit that we wanted to talk about, and that's some different Unicode issues. And so I'm going to hand it over to Eduardo, who's going to talk about that for a few minutes, and then we'll actually get into the filters.
There you go. So, well, Internet Explorer and PHP, Java, etc. have very interesting behavior regarding Unicode. Well, first I will start with Java. Unicode is right now on Unicode 5.3 something, and Java started merging and modified Unicode at 3.0. So everything, all the security enhancements that have been done since that time have been disregarded. So Unicode with introduction. They use the first bit of a byte as a flag to know if it's Unicode or ASCII. If it's 0, it's ASCII, and it's treated as a regular ASCII character. And if it's 1, it's treated as Unicode. And then there are several rules. The first three bits have to be 110 for 2 bytes. And then the second one, 10 and anything. And then if you want 3 bytes long, it will be 16-bit char, and it will have to be 1110, and then 1010, etc. And well, and so on go on. Anyway, there are things that are called overlong UTF. And this is several ways to present less than char that is used for cross-site scripting, but can be used for anything else. So there's this 3C, that is a common representation. C0BC, that is an overlong representation of the same character, and E0, A0BC, If0, C0BC, etc., etc., etc. Unicode for this is in Unicode 3.1. Anyway, it's disregarded on Java, PHP, and etc. And this is an example exploit. So if there's an IDS detecting your attack and your victim is Java, and you can only change the 3C, the less than char with C0BC, and it's probably going to bypass it. PHP. Well, PHP is worst. Their implementation of UTF decode is very bad. They declare C as an unsigned short, and then they use it to put 21 bytes inside it. And this is the actual comments of the code. So they know that they are overflowing, and they don't care. Anyway, this means that you can put invalid Unicode that will not be detected even by filters that are Unicode aware and that overlong aware. So this is a specific attack against, PHP. There's also another attack called eating shards. So let's see that you have something like this. This is very interesting. Normally, this shouldn't bypass the filter, any filter at all. Anyway, PHP-UTF decode will transform this into this. And it will execute your code. This also works on Microsoft products in Chinese. I thought this worked everywhere, but anyway, this morning, Eric Lawrence, we were trying to reproduce this issue, and he showed me that only Chinese version works. So this is a downside of being in China. So in terms of the filters, now David Lindsay is going to present PHP-IDS and mod security, and then I'm going to present Internet Explorer and NoScript.
Thank you. The good thing about switching back and forth is I can make sure how we're doing on time-wise. So I know I need to go through the next slides pretty fast. So I'll talk a little bit now about the first two of these filters here, mod security and PHP-IDS. And we'll go through them pretty fast because a lot of the more interesting things that we have to talk about are going to be with Internet Explorer 8 and NoScript. So first off, mod security. Why did we consider this one of our favorite filters? Well, one, we really like that it's open source. It's easy to integrate into Apache. Anybody here can download it and run it on their Linux server or whatever. And so it's got that going for it. On the downside, the filters are pretty ineffective. As far as I can tell, they're not frequently updated. And again, as far as I could tell, the filters did not support very many different types of encodings. And so there are actually, the first one there is a pretty major downside if that's what the filters are meant for in order to catch things. So, but we wanted to include it in our talk still because we think that there's a lot of potential there. I'll leave it at that. There's a lot of potential. So, first off, most of the filtering happens in just one filter. I apologize if it's hard to read, but basically the filter works in two different phases. There's the first phase is that it tries to flag certain keywords, basically, and if any of these keywords are hit, then it passes it on to the second filter, which is a little bit more advanced, but again, it's mostly just keyword filtering, as far as I could tell. And so that's kind of how the main cross-site scripting filter works. It's all just right here. Now, to be fair, there are a few others, or at least one other filters within mod security that catch different variations of cross-site scripting. But kind of, as far as I can tell, most of the work was happening just right here. So in order to bypass this, it actually doesn't take a lot of work. So let's go through a quick example. So the filters will catch something like the image tag that's at the top here. So again, I'm just using an event handler. When the image fails to load because that's a non-existent URL, the alert will fire. So good, the filters catch that. But how can we change that up? Well, in this case, it's something as simple as breaking up the alert into two words. So if you take the middle example here, we have alert, and then %2b, and then the rest of the alert. Well, so AL, %2b, and the rest of the alert. The %2b is just a plus symbol. So in JavaScript, that's just going to concatenate the two strings together, and voila, you've bypassed the filters with a plus sign. So, and then there's a few different variations of that I include here on this slide. So again, that did not take a lot of work to bypass, and it's kind of sad that the filters aren't able to catch little tricks like this. Another example, I wanted to show something that's a little bit more realistic in terms of what an attacker would actually be doing. So I tried to implement or inject something that'd be like a cookie logger. In this case, I did an image tag with the source of something, and in this case, let's see, what did I do here? Oh, so the filter catches the first one, but on the second one, it does not get through the filters, or excuse me, the second one does get past the filters, and that's because I had to change two things. If you notice, I broke up the source at the beginning. So again, I used %2b, the plus sign, in order to break up source, and then at the end, instead of doing document.cookie, I used document bracket cookie as a string. and that was all that was needed to bypass. So again, these are very, pretty straightforward basic techniques, and it'd be nice to see the filters in mod security improved to the point where they can catch these types of obfuscations. That's pretty much all I want to say in mod security, just because there's not a lot of interesting things going on there. If you are new to cross-site scripting or secure web application security, and you want to practice, it's a great place to start out. Install the core rule sets, and you can practice, how to get by them. The same kind of goes for all the other filters too that mod security uses, like for SQL injection and HTTP response splitting. Pretty easy to come up with bypasses. So. I wanted to point out that it would be nice, there's an OWASP group that's formed that is to improve the core rule set. I even joined the group a few months ago, hoping I could participate in the discussions and improving the filters. And well, the screenshot here is of their mailing list. We've had 2 posts in the last 6 months, and so not a lot of activity going on there. But I think there's a hope for the future still. I noticed that tomorrow there's a breakout session for the mod security filters, so I'm going to attend that. Hopefully, something interesting will come of it. So that's it for mod security. Okay, next is PHP-IDS. Now, this is a really interesting one that I really like. I don't think it's not as familiar to as many people, partly because it's PHP specific, which kind of limits the scope that it can be used in. But what I really like is that it's very aggressive in the types of things that it tries to catch. It is entirely blacklist-based, blacklist filtering, and very focused on specific types of attacks. And the types of things that goes after, that it tries to catch, I really don't see in hardly any of the other filters. It tries to catch things like JavaScript injections, where you're injecting cross-site scripting directly into JavaScript into unquoted strings. So if you think about that, all an attacker needs to do is something as simple as alert 0. And that could be, or the more malicious equivalent of that, eval name, and you have an injection. So for it to be able to go after and try to catch those types of injections is really kind of ambitious of it. And at first I thought it was kind of futile, that there are just too many variations. And in the end, there probably are. I think there's always going to be different ways that you can obfuscate JavaScript that will bypass the filters, as long as they remain very specific blacklist focused. But on the other hand, they have been continually refined and polished over the last couple of years through people that have been bypassing them. And this is due to the fact that there's a demo page where you can create bypasses and submit them to the maintainers, and they are very active and aggressive in terms of getting these filters fixed. So I think that whole fact that they have this demo page where you're encouraged to find bypasses and submit them has really helped improve the filters. And so that's something I like to see incorporated in other filters, so that they can be improved as well. Okay, so I just want to talk a couple bit about the disadvantages. It can be slightly, add some overhead since it's running on your same server, and it is prone to false positives. I think there's Mario's, one of the maintainers, has done a lot of work in eliminating those, but it's going to be an issue. So I pretty much talked about all of this already. Okay, so let's talk about some of the filters themselves. So the filter works by having a bunch of these regular expression filters. I included one of them here, and it is kind of this nasty, gnarly thing, but basically this is something that's trying to catch things like eval statements that are being included in your JavaScript. And so the filter as a whole includes about 60 or 70 different filters like this. And not all of them are cross-site scripting specific, but a good number of those are, at least 50% are. So there's a lot of filters that are like this that are specifically targeted to different types of JavaScript and HTML injections. So I wanted to kind of real quickly go through the process of how you'd actually do a bypass. I'll do these really fast, and we can look at the slides after to see kind of how it works. So you start out with something like eval name. That would be, in this case, an injection directly into JavaScript, which is something it's supposed to try to catch. So, and in this case, it does. It triggered several of the filters and assigned that a score of 17. And so if I can get that score of 17 down to 0, that means I didn't trigger any filters and I successfully bypassed. So how can I modify this in order to maybe get around some of the filters? Well, let's try to break it up a little. So you do something like this, have eval be its own variable, name its own variable, try to call it in its own way. Okay, that gets caught as well. So again, well, maybe we can keep refining it further. So we do this a few times and we end up with something like this. And you look at the impact score of this injection. You're like, oh no, we went from what, 17 up to 62. Things are much, much worse now. And on the one hand, yes, that's the case. But on the other hand, based on my knowledge of the filters, I know that I'm kind of getting someplace still, because I know that I'm getting to a point where I can maybe make a few more changes that will get around the filters completely. So if we keep obfuscating things a little bit more, then you can and look at the specific filters that are being triggered. You can come up with different tricks that will bypass the different filters. And it's a very time-consuming process, but if you do it, you can end up with something like this, and refine that a little bit more. You end up something like this, and and then for the last little bit, we have to include the string at the very end, which is basically just ASCII text, mostly just ASCII text. And this is in order to bypass the centrifuge filter that it has, which is just a ratio of good characters to bad characters. So basically, I just need to include now a whole bunch of good characters. So I throw them onto a JavaScript string here at the end. What I did here was not quite enough, so I just make the string longer. So there you go, ... And by making it long enough, I now have bypassed the filter. So this is something, this is an example of a bypass that actually would work of the filters. So yeah, there's a lot of obfuscation tricks, and it took a lot of work to develop this, and that's why I think that the filters do a really good job at catching the basic things. I mean, if you just sit down, you're not going to come up with something like this in a couple minutes to bypass the filters, unless you're really, really good at JavaScript. Okay, so that's the filter. If you want to see proof of concept of this one, how it works, it's there on my site. After it gets, this particular injection will get fixed. Obviously, it's not going to work anymore. I normally wouldn't just drop a 0-day like this, but Mario was leaving on vacation, didn't have time to fix it, and he said to go ahead and include it in the presentation. So it's all with his blessing. Okay, so I wanted to include here a couple other examples of how the filters are bypassed. These are just kind of cool because they each use some novel tricks. On the first one here, you see the VBS trick that we talked about earlier, using VBS, an event handler that got past it. It's now fixed. The second one is just a way of using regular expressions to kind of hide things. That got past it a couple months ago. The next one here is one that Gareth Hayes found, which is really clever, using set timeout in order to execute an alert. And the last one is one Eduardo found just a few weeks ago, and this is kind of like a parsing issue where you might think that the script tag is in quotes as part of the attribute for the B tag or something, but actually it's not, and so this was bypassed the filters as well. It's now been fixed. So that's PHP-IDS. So it's actually a really, really useful tool if you do have a PHP application or I think it's been ported to a few other different languages, like Perl. So if you can, and you're looking for something to catch types of injections on your website, it can be really helpful. Okay, so next, Eduardo, we'll talk about Internet Explorer 8 and then NoScript.
Yeah. Okay, so, well, Internet Explorer 8 introduced, among many other security features, a cross-site scripting filter developed by David Ross. And, well, it's actually very good. It was covered in some part by Kusa55 in his presentation in OWASP Australia. So if you were not in Australia, you can see part of it here. Oh, no? Yeah. Well, there are 3 commandments of the cross-site scripting filter. It should be compatible, it should be secure, and it should be performant. So all the decisions that are made in the cross-site scripting filter are based on these 3 commandments mainly. So the users can disable this either for any reason. So if it's not compatible, the users will turn it off. And if it's not performant, the users will turn it off. The same for servers. You can also disable it from the server, from your website, sending a HTTP header. So if it's not compatible, administrators are going to disable it. And if it's not performant, also going to be disabled. So what does this mean? The cross-site scripting filter is going to protect only against the 3 top cross-site scripting attacks that are simple HTML injection, simple attribute injection, and inside a scripting tag. So the rules. There are a lot of rules. If you want to see them, you can put this into your Windows machine, the DOS, and you're going to see the rules. There are regular expressions in general, and they're all like this. The request is like this, bar script. And then the rule that is matched is this one, script. So the response, then the filter looks in the response if the matched request is sent. And then it does another signature stuff, and then it matches the element in red, and it nullifies it with a hash number, with a hash symbol. So, well, bypassing the filter. There are he protects against the top 3, but there are still top 10 reflected attacks. So therefore, when you have fragmented attacks, this is not very common, but it's still very common. When you have 2 inputs like this, you can bypass it. This is an example where you can, well, the user is only using HTML entities instead of HTML entities, comma, and quotes. And, well, this is a bypassable scenario, for example, because you have 2 injection points. DOM-based, stuff like when people do document.write and your string, or inside event attributes like this. This is very common on forums and stuff like that. Number 7. Oh, well, it's gone? Well, I don't know. Reflected cross-site scripting means that the attack has to be present in the response. So if the response is modified a little, maybe a str to lower or stuff like that, it's probably not going to be detected. Attacks that abusing char set peculiarities that we already talked about in the Unicode part, and attacks that are not reflected in the same page. I will try to do a quick demo. Whoa. Oh, maybe here. I have to do what? So this is a very simple proof of concept because the no, actually it's not here.
You want IE or Firefox? Or?
No. I copy wrong.
This is IE.
So this is just an example of several websites that actually is very slow. Yeah.
So all of our internet is going through my little BlackBerry here, which is acting as the modem, which is terribly slow. So there we go.
The problem here is that the CNN website, no, it is java.net. Yeah.
Java.net.
This java.net website is redirecting us to our error page, and he's saving the session in the cookie. So, well, this is an example of a filter that, no, is this one? No. Where is it? Oh, here it is. This is an example of an attack that won't be detected. And well, top 10. I had a demo for this one that uses the router, but the router is bricked, so I cannot use it anymore. Never mind. Using CSS-only attacks. As David already told us, there are ways to make CSS-only attacks that don't use JavaScript. So stuff like this can be used to read CSS, an attribute, and you can also reconstruct the DOM and the way it works. So stuff like this, when you want to read the source code of a web page and then read announs or something like that, if you have an injection point before, then you are going to receive everything until the next single quote. So if this is a little more explicit, the website that is going to be sent to your site is going to be everything in green until the next single quote. This is also not going to be detected. Other exceptions, intranet. The Internet Explorer filter is not enabled in the intranet by default. So you can do attacks on intranet websites. And same origin. Well, if a website is attacking itself, it's considered trusted. So it's also not detected as an attack. So you can also use the same origin exception as an attack using clickjacking. This won't work. This won't be detected. This attack, since it is using the same origin exception, and everything is inside an attribute tag. So this requires an extra step from the attacker. It requires the user to try to click anywhere in the web page. So if the user tries to clicks anywhere in the web page, if it works. Yeah, well. So, well, this is a website, the CNN website. And if the user tries to click here, for example, instead of clicking what he thinks he clicks, he was, he's redirected to the attack. This is a very easy way to bypass the filter. Probably the best way you can bypass the filter. Anyway, it still requires user interaction. You can also disable the filter if you have a new line injection. If you have something like this, then you can just append the header that will disable the filter. The bypassing JavaScript filter, there is a way. You can bypass the JavaScript-based filter just by, because the filter assumes that it's impossible to execute without equal and parentheses. Anyway, it's possible to do this. using this string. It actually works using inner HTML and setters, and well, it's a little complicated to explain. We're running out of time. Well, we're limited to attacks inside like this. So well, if you use this attack, you can actually bypass the filter. And some JSON parsers, like some that do Google Gadget EO JSON parser, may be also bypassable like this. Because they do eval, and they check for new, and parentheses and equal, so it's actually bypassable.
Eduardo, I just wanted to mention that a lot of the bypasses that were talked about earlier were ones that Internet Explorer wasn't really meant to catch in the first place. It's just trying to get a certain class of cross-site scripting vulnerabilities. But this one that we just showed is actually one where you are escaping out of a JavaScript string, which is one case that the filter is trying to catch. So I just wanted to point out that that's a major difference in that last one that was just shown. So.
Well, other possible bypasses using new. You can execute user function inside the code. You can do it like this, use locations inside ternary operators. You can also use ternary operators to replace the string, and well, rewrite your functions. If you rewrite a function and then some script in the client side, like Google Analytics or something like that, use escape and the referrer, then you can probably bypass the filter. Disabling scripts. This is very interesting. You can actually selectively disable scripts inside a web page. So if you have something like a frame breaker like this, then you can just use a request like this, and then after the filter, the frame breaker is going to be disabled. Well, I don't think we have time to a demo. Anyway, we can also bypass content-aware filters. Content filters that are like this, and you can inject inside, but you cannot escape from the string. You can just disable the script, and then the content that is inside is going to be loaded as HTML. So I asked a lot of questions to Microsoft. You can see this in the presentation slides because we have no time. So the motive of fragmented attacks is because it's very complex. The algorithmic complexity is very high. They don't detect DOM-based attacks because it's not in their current feature set, but it will be allowed in the future. And they don't detect non-JavaScript attacks like the Anchor attack right now, well, because some websites use it. And well, the reason they don't detect attacks on intranet is because some websites may be broken. And if Internet Explorer is protected against reflected content scripting, should the developers disable all cross-site scripting defenses? And the answer is yes, of course. So cross-site scripting filters in other browsers. Firefox, never. They have content security policy. That's a very good solution. Firefox and NoScript has a cross-scripting filter since a lot of time ago. Opera and Safari, I have no idea. And Chrome has a prototype. So, NoScript. NoScript advantages. First of all, the users are already security aware. They already know that the web is an insecure place, and etc. They prefer security over reliability. Anyway, NoScript is very, very usable. NoScript gets updates every week, every 2 weeks. They're very, 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 very frequently. Also, it's not just a cross-scripting filter, it's just a feature. So they have a lot of things that protect you against a lot of stuff, even if you don't require the filter. Even if you bypass the filter, I mean. So, as any other cross-scripting filter, it is still possible to bypass NoScript. This is a bypass that worked last week. I don't know if it was fixed. Yeah, it was fixed. Well, I'm not sure if it was fixed. I notified it last week, and I saw an update, so maybe it was fixed. I didn't have time to do this. So, hacking the filter. The doesn't-pound NoScript attack. If you can use a denial of service attack to NoScript, then you can kill NoScript in all the web page that is loaded. So, if you actually disable NoScript in the web page, all their cross-site scripting filter and stuff are going to be disabled. So, if you put a very long and complicated JavaScript string that is going to take a lot of time to NoScript to parse it, you're going to be able to hack it. Same exception is the same as in Internet Explorer, and now you require things that are inside a iframe. So if your website, like Google, for example, allows stuff like open redirections and framing, this is an example in the image results website. then you can actually bypass the filter if there was a vulnerability in Google AdSense, that there are not, of course. This is the last part, tribute to the super IDS. This is actually a little funny. It's very easy to bypass a lot of filters. So there are a lot of filters that can be bypassed. I couldn't have time to test more, but these are some of them. So the rule number 1, if you want to bypass a lot of cross-site filters, stop using alert cross-site scripting. You should now use prompt cross-site scripting. If you want, rule number 2, stop doing script. You should now use uppercase and stuff like that. Rule number 3, stop using, this is for SQL injections because this is awesome. Now use or2 is equal to 2.
Okay, it's not cross-site scripting, but hey, we had to throw it in.
This bypassed imperva is amazing. Instead of using union select, you use the standard way, that is union all select. Instead of using etc. password, you can do etc. password. This is for local file inclusions. Rule number 6, instead of calling, they detect URLs in the request string. So you can only use HTTPS, and you will be able to bypass them. And well, rule number 7, instead of calling your website, this is for mod security. They are completely, they detect if the website is called c99.php, shell.espx, cmd.esp. So if you call your shell ruffle.php, it won't be detected. So conclusions, for Internet Explorer, you should use a filter. You should enable the cross-site filter in the intranet zone. I forgot to put that. If you use Firefox and NoScript, obviously. If you use an IDS for web filters, well, use mod security. Don't use mod security until the filters are better. Use PHP-IDS or WebScarab or Apache. Well, there are a lot of another based on the same rules. For synthesizing HTML, use HTML purifier and anti-SAMI approaches that are very good, actually. And if you have to maintain an IDS or WAF, set up a demo site. Well, so people can test them and ensure that they are safe, if they are safe at all. And don't trust your RDAs because it will be bypassed.
I just wanted to interrupt real quick
Yep.
to emphasize one point. So we did look at, as we went through some of these different filters, we did find and show how they can be bypassed in different ways. And I don't want that to be doom and gloom for the filters. That doesn't mean that they're useless or they're not effective. They actually do quite a good job of all the Internet Explorer 8, NoScript, and PHP-IDS. So you shouldn't lose faith in the filters just because it's possible to find bypasses in them. But in each of these cases, they're all very useful, and we highly recommend using these three. So
yeah. So well, there are the. Oops. So yeah, it's all. Thanks to everyone, and that's it, I think.